Today we'll discuss a problem on method of joints. Analyze the truss shown in figure by using method of joints and indicate the forces on the truss. So this is the truss given in the question. So inclined force is given at this joint B. So A, B, C, D, E are the joints, and at D you have a roller support, and at E you have a hinged support. The spans, height and spans are given here, and there is an external force at C 20 kilonewton, and at A you have 10 kilonewtons. So coming to solution part. So first of all, let us draw the free body diagram. Okay, so we'll remove the supports and we'll show the forces. For roller support there will be one reaction, and for hinged support there will be two reactions. Right, so this angle is theta. So we can find theta easily. First of all, tan theta equal to is 4 divided by 3. So theta is 53.13. So if this is 53.13, this is also 53.13. This is 90 degrees. So we can easily find out this angle. Angle CED equal to 180 minus 90 minus 53.13, that is 36.87. This is also same, 36.87. Right. Then the first step is to find the reactions. These reactions HD, HE and VE. So we'll use the equilibrium equations to find the reactions. So what are the equilibrium equations? Sigma fx equal to 0, sigma fy equal to 0, and sigma m equal to 0. Right. First of all, we'll apply sigma fy equal to 0. So vertical forces. So we can write here upward forces equal to downward forces. So what are the upward forces we have? VE is equal to downward forces 20 plus 10 and 15 sine 30 degrees. So from here you will get the value of VE, reaction VE. Then sigma fx equal to 0. So left side force equal to right side force. HE plus HD equal to 15 cos 30 degrees. Let this be equation 2. This be equation, first one is equation 1, this is equation 2. Now applying sigma moment about E is equal to 0. So what are the forces you have? This one, this one, this one, all these forces into perpendicular distances. So clockwise forces we are taking positive here, anti-clockwise we are taking negative. So HD into perpendicular distance. So this is anti-clockwise, therefore minus. Then 10, this 10 into 3 plus 3, 6. This is clockwise, therefore plus. So in that way we have to take all the forces here. 20 into 3, next 15 sine 30 into this distance 3. That's it. We will not consider HE, VE and 15 cos 30 degrees because they pass through this E, joint E. So the perpendicular distance will be 0. Then you will get HD from here. So substituting equation 3 in equation 2, you will get HE. So from here you will get all the reactions, HE, VE and HD. Yeah, coming to the next step. Now first of all, let us draw the free body diagram. Let us show the reactions here. Here you have got HE as negative. So let us represent in the same way, HE as negative. So next, now we need to select a joint. In the method of joints, what we'll do is we'll go by joint. We'll analyze using the equilibrium equations. We'll find the forces. Right. Now, when to use method of joints and when to use method of sections. So if in the question, if he is asking to find in a particular members, forces in particular members, then you will use method of sections. But if he is asking to find all the forces in the members, then you have to use method of joints. Right. Now let us write all the joints here. Joint A, B, C, D and E. Then unknowns. At A you have 2 unknowns, B 3 unknowns, C 4, D 2, E 3. So as we have already found the reactions, so we have got these reactions. So at D you have only 2 two unknowns. Right now we can so we need to select that joint which has two unknowns. Therefore here A and A, two joints has two unknowns, so we can select any one. We can proceed from A or we can proceed from D. So let us select joint A. So at joint A we have to represent all the forces. So FAB, FAC and 10 kilonewtons downwards. This angle is 53.13. Here we are taking FAB away from the joint, FAC away from the joint. So in this method we can take in this direction towards also, but I am taking away from the joint to avoid the confusion. So everything I'll take away from the joint. Right, later I will adjust it. Okay, FAB, FAC and 10 kilonewtons. Now what I will do, I will resolve this FAB into vertical component and horizontal component. So vertical component of this FAB is FAB sine 53.13. Horizontal component is FAB cos 53.13. Now I have all the horizontal and vertical forces. Now I will apply sigma Fx equal to 0. So left side forces equal to right side forces. FAC plus FAB cos 53.13 equal to right side there is no force, equal to 0. Let it be one let it put it aside. Then sigma Fy equal to 0. So upward force equal to downward force. FAB sine 53.13 equal to 10. Downward force 10. So from here I will get FAB, force in AB 12.5 kilonewton. Then if I substitute FAB here, I will get FAC. So FAC equal to minus 7.5 kilonewton. Next, so A is over. We have got this force and this force. Next, if we go to C, so how many number of unknowns are there here? So this is known, this is known. So 1, 2 and 3 unknowns are there. So we cannot go to C. No, let's go to B. So here how many unknowns are there? This is already known here, FAB. So 1, 2. So 2 unknowns are there now at B. So we can go to B. So at B, this is a free body diagram. So you have 15 sin 30 FBE and 15 cos 30 FBA, FBC. Now I will resolve this FBA into horizontal and vertical components. So here vertical component will be FBA cos 36.87. Horizontal component will be FBA sin 36.87. Now I will apply sigma Fx equal to 0, sigma Fy equal to 0. So horizontal for left side forces equal to right side forces. So from here you will get FBE. Then, so FBE I have got minus 5.44. Then apply sigma Fy equal to 0. Upward force equal to downward forces. So you will get FBC as minus 17.5 kilonewton. Now, then after B, I will go to, so as I already know this force in this member. Now at C, I will have only 2 unknowns. So I will go to C. So at C, there are these forces you have FCB, FCA and 20, FCD and FCE. So whenever there is an inclined force, you have to resolve it into components, horizontal and vertical. So here horizontal component will be FCE cos 53.13, vertical component will be FCE sin 53.13. So you will apply sigma Fy equal to 0 and sigma Fx equal to 0. Here you will get, if you apply sigma Fy equal to 0, you will get FCE as 46.87. If you apply sigma Fx equal to 0, you will get FCD as minus 35.625. Then go to, so after C, then go to D. So you have already you know this. So this is the unknown here. So at D, I will apply sigma Fy equal to 0. So FDE equal to 0. Upward force equal to downward force. There is no downward force. So FDE equal to 0. Right. Then I will go to joint E. So at joint E, I have all these forces. So I will resolve this FEC in this way. So the horizontal component is FEC sin 36.87. Vertical component is FEC cos 36.87. And from here I will apply sigma Fx equal to 0, sigma Fy equal to 0. I will get FEC as 46.87. FEB as minus 5.445. Coming to the next step. So in the step 2, we have solved all the forces. In all the members, we have calculated the forces. Then coming to step 3, where we have to represent all these forces in the form of a table. So serial number, force in the member, magnitude and nature. So FAB, FAC, FDC, FDE, FEC, FEB, FBC. So write all the values which you got here. So place, whether it is plus or minus, just write the values here. Right. So if the value is plus, then you represent it as tension. If the value is minus, then you represent it as compression. Okay. So plus, this is minus, so compression. Then in the last step, so as he has asked in the question, to indicate the forces on the truss here. So we have to indicate the forces on the truss here in the last step. So first of all, represent all the magnitude forces here. Then, yeah, see it A. So we have FAB force. So what is the value of FAB force? It is plus 12.5. That is tension. So if it is tension in nature, you have to take away from the joint. If it is compression, you have to take the direction towards the joint. See, if AC is compression, minus 7.5 compression, so towards joint. Remember this point carefully. So if it is tension from joint, it is away from the joint, and if it is compression towards the joint. Don't get confused, because if you see here, if this is a member, for member AB, it is looking like compression. So we have to not see from the member point of view. So from joint point of view, you have to see. From joint, if it is at this point, if FAB is as the FAB value is 12.5, it is tension. So tension means away from the joint. Compression means towards the joint. Same here also. At B, suppose this, we will see this value FEB. What is the value of FEB? 5.445 compression. So at joint B, compression, so towards the joint. Similarly, if you see here, suppose that at D, DC, what is the value of FDC? Minus 35.62, that is compression, so towards the joint. That's it. Yeah, this is how we analyze the truss using the method of joints. Just we have 4 steps here. First we have to find the reactions, and then we have to find the forces in all the members, and then we have to show in the form of a table, and then indicate the forces on the trusses. That's it. Thank you.